Hi, good afternoon, everyone. Today I'm going to talk about how you are going to use in your SPSS software, very basic things. Also, depending on the data and variable, how you are going to choose what type of analysis you are going to run for your research project. Okay. uh, Statistical package SPSS actually we use for the different type of quantitative data analysis. So today I'm going to talk about how we are going to use the SPSS software, and the main outline of my talk will be, first part will be types of data and variable. You will get to know about the data and variables separately, and then the types of statistical analysis we use, and also how we are going to select what type of analysis will be suitable for us and how we are going to proceed. Okay. And the third part will be how to explore data for normality, which is essential part of any statistical analysis. Like if data is parametric, you need to do one type of analysis. If non-parametric, then you need to do another type of analysis. And the last part will be how you are going to enter data in your SPSS. Part one, as I mentioned, the types of data and variable, because before starting any statistical analysis or anything, any of your research project, you need to know about the data and variables. Actually, there is difference between the data and variable. Data are the facts or information used to calculate, analyze, or plan something. Like we collect data from the hospital side, like from the patient information, or IPSAKit, we get different patient, different information. Those are the data for those patients. Okay. So depending on the types of data collection, actually there are two different types of data. Data we call, one is primary data and one is secondary data. The primary data are which are collected as a fresh and the first time, like when you go to a new patient came, you are collecting the data. That one is the primary data and original data what you got. But from the IPAC circuit, sometimes we retrieve the data, or for our study purpose, you took the 10 years previous information from any, suppose from the cancer registry or any of the information center, you took the data and then you use it. That one is called secondary data. The secondary data actually a bit more clean, or sometimes labeling, coding, everything is done. Often you are asked by the evaluator or examiner, like what data you use for your own study. So sometimes you do primary and sometimes you do secondary, but in case you use secondary data, you need to justify why you use the secondary data. Okay. After the data, you need to know what is variable. Okay. A variable is any characteristics or quality that varies among the members of a particular group. Okay, like the gender, race, age, intelligence, anything. Those are the variable. We name it. Okay, those group of, the name of that group of particular people or particular thing or particular activity, what we name, that is variable. And what the information we put for single people, that one is data. Okay. So variable actually can be classified many different ways, but for your own purpose, I just put two main important types of variable. One is dependent variable, one is independent variable. From the name, you can guess, like an independent variable is variable that doesn't depend on anything, and the dependent variable actually depend on something. Okay, like sometimes your age or your ethnicity or your religion, these things are independent variable. You cannot change this, right? But dependent variable depend on the independent variable. Sometimes like your exam marks will depend on how hard you are working, your dedication, or your like how keen or how meritorious you are. Depending on those things, your exam marks can be vary, right? So that one is dependent variable. There are some important example, like if someone asks you how stress affect mental state of human being, the first thing it comes like stress is independent. Okay, stress dependent variable is the mental state of the human being. So stress doesn't depend on mental state. Okay, on the mental state of human being depend how stressful your life will be, right? Like the others, like salary of the employee. Okay, salary of the employee, if you see from the term, like your salary actually depend on different things. Okay, how competent you are, when they hire you, maybe how educated you are, maybe your age and experience. Those things are your independent variable. Okay, so there are another type of we can classify variable in another type based on nature of the data, which is we classify categorical variable and numerical variable. Okay, this category actually also used for the level of measurement, and this category is very important for your type of analysis. Okay, so the categorical variable are nominal and ordinal variable. That means when you can that variable or data you can categorize. So it's two type, nominal and ordinal. When you can order it, we call it ordinal variable. When you cannot order it, we call it nominal variable. Okay, like you can see the sex of the people, male people, you cannot order it, like you cannot put which one comes first or which one last, or blood group of your patient, or maybe the other things like ethnicity. In Malaysia, Malay, Chinese, Indian, like this. But the ordinal one you can put in a order, like mild, mild, moderate, severe, or maybe you can put the stage of the disease, stage 1, 2, 3, 4. So you can, or first, second, third in the exam. So it's ordinal one, order you can put. So this based on the categorical one, but the numerical or scale variable is also divided into two types. One is discrete and one is continuous. Continuous one, normally what we measure, like height, weight, those things. But the discrete one, what can be counted. But both discrete and continuous one are in SPSS term as a scale variable. Okay. So these are the example as I just mentioned, like numerical data, continuous and discrete, and the categorical data, ordinal and nominal. Okay. So there are some other name of the dependent and independent variable you can hear from lots of people. Like dependent variable often will be asked, what is the outcome variable? Okay, so the outcome of your study, like if any in your project you are going to see if patient is exposed to something, does he has cancer or not at the end. So the outcome is cancer for this project. Okay, or something like that, whatever you measure at the end, that is your outcome variable or dependent variable. It is another name of the outcome variable is dependent variable. Okay, or another name is response, explain, predicted. And independent variable are often called covariate, stimulus, explanatory, or predictor. Among these, covariate is very common term that you will hear often. That's independent variable, like any of the model of your project, you need to adjust. Like age, sex, ethnicity, different things. Those are the covariate we often adjust in our model. So after you get to know the data and variable, I'm going to explain you type of statistical analysis and selecting appropriate type of analysis. Okay. Before you know the type of statistical analysis you are going to do or choose, you need to know what is statistical analysis. We assume like statistical analysis means only doing analysis, but statistical analysis means when we collect the data or thing, organize it, and then analyze it, and based on that we interpret it. So that's actually the whole thing called statistical analysis. And the statistical analysis mainly two types. One is descriptive and one is descriptive one, and one is inferential one. Descriptive one is simply like whatever describing your data. That's very simple thing, like when you need to summarize or describe the distribution of a single variable. Okay. When you want to understand the relationship between the two and more variable, you need to think different way. Okay. During COVID-19, there was clinical trial done to see the efficacy rates of COVID-19 vaccine. So it's simple, this one present like 95% Pfizer was effective for in this clinical trial, then Moderna 94%, like this, the simple percentage, how effective the vaccine was in the clinical trial. This is a descriptive analysis. Okay, simple, anything like in your study, how many male, female, how many different ethnic people are there, how many cancer patient is there, something like that, very simple one. Two general type of statistics we do in our basic descriptive statistic. One is the measure of central tendency, that is mean, mode, median, and the measure of spread like standard deviation and other things. This is the chart you can remember. Normally this is the most common one, but sometimes there is some exceptional one. Like for nominal we use mode, for ordinal we use median, but for interval and ratio depend on the parametric and non-parametric, we often use mean. But when the data will be skewed or not normally distributed, you need to use the median or interquartile range. Okay, so from the central tendency, the mode, the category or value in data has the highest frequency, most commonly appear on the data, that is called the mode. Okay, the median one is if you arrange the data like ascending or descending manner, the most middle value is called the median one, right? If it's odd, then odd number of the data, then you will get one middle value, the median. But if it's even, then you will get the two. And the mean we use most commonly, which is the average, arithmetical average of the data. So any data we call normally distributed data seems like this in the bell curve shape. Not normally distributed data will be like this. When the data is normally distributed, the mean and median will be same. Okay, but when not distributed, then mean or median are not same. This thing you might not understand now, but later when you will go more, you will understand better. Then the second type of statistical analysis we do is inferential statistical analysis. This is the advanced part of the descriptive statistics. Okay, inferential statistics analysis is used to make inference or draw conclusion about a larger population based on finding from a sample group within it. Like for our study, any study, we have a big population, right? Like we want to see any colorectal cancer patient, but there are many colorectal patients in Malaysia, different hospital, different. But for UMC, if you take the colorectal patient, this is your sample, but this should inferential statistics will reflect like your data of that colorectal cases, does it reflect, or can you generalize your finding for this colorectal patient for all the colorectal patient in Malaysia, or for all the patient in the hospital or different hospital or at different time point? Okay, that's inferential statistics. Or inferential statistics also help us to measure like how confident we are to find that our finding we can generalize it or not. So there are some example like hypothesis test. We want to compare the mean and see whether there is any difference or not. That's hypothesis test is for hypothesis test, we do the inferential statistics. Then for the confidence interval, then correlation or regression, like relationship or association between the two variable or different variable we want to see. Then we run different type of statistical analysis. Okay. As I mentioned before, the variable defined different way, like the categorical one and the scale one. This is the measurement scale we use for the SPSS. Okay, you can see in the measurement scale part in the SPSS, there is nominal, ordinal, and this interval and ratio actually under the scale variable. Okay, like any number thing that you can count or you can measure, those are the scale variable. I'm not going to details here. This is one plot, like how you can be sure like what type of scale variable you got. Okay, this is a golden table. Now it will be quite difficult for you to understand, but this is useful when you want to see what type of analysis or what you are going to do. It gives a broad picture for you. Okay, then the part 3 of my talk is how to explore data for normality, because we decided we will do some analysis, but before analysis we need to explore that our data, what we take from the population as a sample, is it normally distributed or not? Okay, the data distribution, the Gaussian or normal distribution, is the most significant distribution that's used in the statistics. Okay, this looks like a bell curve. If you see the data, your data in a histogram, it looks like this, exactly like this, or nearly normal like this, not too much deviated, then you can say your data is normally distributed. Okay, like this one, you can see data is normally distributed. This one is not that normally distributed, it's skewed. Okay, so for testing the normality of the data, you need to keep in mind all the data must be tested for normality before analyzing any type of statistical, analyzing them statistically. And data cannot be exactly normally distributed. If it's approximately normally distributed, still it's okay. And the type of normality, if data is normally distributed, we use the parametric test, which are like t-test, ANOVA, pair t-test, ANCOVA. Those are the Pearson R or correlation. Those are the analysis we use for parametric, if data normally distributed. If data not normally distributed, then we use non-parametric tests like chi-square test, Wehrmann-Rowe test, Mann-Whitney test, Wilcoxon test, those tests. Okay, so to check the data for normality, there are certain methods, and always remember we check the normality of the dependent variable. Okay, and if you got the dependent variable, and it should be checked, okay, for each category of independent variable. Suppose you are checking the something like how satisfied your patient are after the surgery or something, then you must, that's your dependent variable, but you must patient satisfaction is your, but it's independent variable are which depend on, like, is it male, female, or they have any comorbidity or anything. So you must explore for each category of independent variable. The like if I have different sex, male and female, then I will do the satisfactory score, run the normality test for satisfactory score for both male and female separately. Okay. So there are some rules we can follow to check in the SPSS to see whether data normally distributed or not. Like there are two parts. One is numerical, like from the number we calculate and see, and another part is visual, from seeing like just before I show you like data distribution, like a bell curve, we can say, okay, it's normally distributed. So there are a few rules like skewness and kurtosis Z value we measure for this. It should be somewhere in the span of minus 1.96 to 1.96. We will calculate it. I will show you later. The Shapiro-Wilk test p-value we also measure should be above 0.5. Then we can say data normally distributed. Okay. And we also see the histogram normal QQ plot. You don't have to be confused. If you see only the histogram, should visually indicate that data is normally distributed. Okay. This is one of the example I'm showing you. Normally we go to analyze, descriptive, and then we do the explore. And then we dependent, if I see here I actually try to explore the perceived score of knowledge before the campaign, okay, based on the ethnicity, different ethnicity. So I take the histogram and normality test for the plots, okay, and then the result in your SPSS you will get many results, but the three things we are going to calculate for during workshop also I will show you. Normally we will see the skewness and kurtosis Z value, okay. According to the rule, it should be somewhere between minus 1.96 to 1 plus 1.96. Skewness and kurtosis, how we need to do by hand, okay, calculate. Like you can see in the SPSS output, skewness statistics here and standard error here. So for the skewness, you need to divide the statistic divided by standard error, which shows 0.525. I assume this is between this range. Okay. For kurtosis, I will go to do also this one, statistic divided by this one. Okay, standard error. And then a number will find if it's between these two range value, then we can say data actually normally distributed. This is one rule, first rule, okay. Then we check the normality test for the test of normality. You can see in your SPSS. Most commonly we use Shapiro-Wilk test. Shapiro-Wilk test there is a table like this where you can see the significant p-value, okay. The significant p-value is like this. Like I use the different category, like Malay, Chinese, Indian, and other different categories. You can see none of them are significant. All of them p-value. This significant means p-value. This p-value more than 0.05. That means all data are patient knowledge before campaign was normally distributed for different ethnic group as well. Okay, so that means my data is normally distributed, and I can interpret like, okay, I can interpret or tell like, okay, patient, normal people knowledge also, different ethnic group knowledge also can reflect from my study. The third part of the normality test is this one, like the histogram, the visual one should visually indicate that the data is normally distributed. You can see the Malay one I show only. I draw the histogram plot and then bell curve. It shows it's almost nearly normal, you can see. Okay, so tomorrow, for your workshop tomorrow, I'm going to show you how you are going to run the normality test. And the last part of my talk is the data entry in SPSS, which I put different things, but if you see it's how to enter individually, then it will be more clear. But you need to keep in mind certain things, like when you enter your data in the SPSS, it must begin with letter. It should be unique for each another variable, and there shouldn't be any space, okay, and no character you can use, special character, except the underscore, okay. And character should be, variable name shouldn't be too long, less than 64, okay. If you open an SPSS dataset, it looks like this, empty one. You got two windows, the data view and tab, data view tab and the variable view, okay. The data view, you need to enter the data column wise. Here we will enter different, suppose different patient, different information we can put here. And the variable view, you can see the name, type, white, decimal, label, values, missing. These are the different title. It's already in the SPSS. So once we start putting the information, it will be automatically appear, okay. Suppose I want to enter my data. First thing, I want to put the registration number of the patient. So I will type here registration number. You can see you cannot put any space, so I just put the underscore. So registration number, sometimes we put only RN number, so it's numerical, automatically selected, and then this part are blank, unknown, these things, okay. The next thing we label it, which is very important, because whenever you run analysis, your output will be shown from the label. So we put like registration number of the patient, we can label it here, okay. Value, no value, still, alignment, those things are, and but for the measure, if you click, I told you before, the level of measurement, like scale, ordinal or nominal, you can put, because it's a number, so we can put the scale, right? We cannot order it or we cannot nominal. It's not a categorical one, right? So this is what. And then the second variable, I put like ethnicity. There is another thing for the variable types, is automatically select numeric, okay. But sometimes if you want to put date, like June 6, 2020, 2022, different date of birth, you can select the date and then it will appear different way, okay. So this is another thing. And then decimal is like 0.002, how many decimal you want, it's depend on this. Mostly we put 0 here. Then once the ethnicity I put for here, ethnicity of the cancer patient, I can label it, okay. Then the value is still not there, but I need to code the value. Like suppose I got Malay, Chinese, Indian, others. So what I can do, Malay one value one here, label Malay, and then add. It's like this. I already added here. Then 2 Chinese, I added here. Then 3, label it Indian and add it here. So it will be like 3 equals to Indian, and 4 I can put others and add here, okay. So it will automatically label. The coding is useful, okay. So another important thing when you enter your data is the missing variable. Sometimes we don't have any missing variable, but sometimes we can get the missing information. So what we put, sometimes we put only dot, but in case, or we keep it blank, but in case you need to analyze something and you need to take out the unknown variable or missing variable, unknown or missing one, you need to label it. So you can put the missing, you can click here discrete missing values, and then you can put 999. So when you go to data information, if you put anyone's information 999, SPSS will take, like for this one, for ethnicity, here I make, not for this one, I make here. For ethnicity related, anything I will do, if there is any 999, SPSS will take it as a missing value, and some of the advanced purpose, it will take it out. Okay. So this missing one is very helpful. So after entering the SPSS, which we will go in details tomorrow, I want to explain a bit more, although it's not useful now, but you need to know like how you are going to choose, okay, your statistical data. As I mentioned, depending on the outcome data or outcome variable, we choose the statistical analysis. If the outcome data is, you need to think, is it continuous or it's categorical? I can categorize or I can continuous one. If it's continuous one, you need to think what you are planning to do. Okay, are you planning to compare the mean? Okay, or are you going to see any relationship or association in the continuous variable? If you have someone height, weight, you measure BMI, okay, for the patient. Then you say, okay, patient with obese patient got more specific type of cancer. So obesity and cancer one you want to see, but then you take some case and control group of patient. One have cancer, one doesn't have. Then BMI is a continuous one. So you want to compare the BMI, which is number, between the cases and control. Maybe you can compare the means like this. Then what we do, first thing, as I mentioned before, we run this normality test. If data is normally distributed, yes, that means we need to do parametric test. And if not normally distributed, then we do non-parametric test. If we choose the parametric test, we need to think like, is there two group we are comparing the mean? Okay. Or suppose that you want to see the exam score. Okay. Like first year, second year, third year, fourth year, something like this. You want to see exam score in first year and same student, first year and second year. So the first year and second year is the two group, right? It may be pair sample, but two group you are comparing. So the mean exam score of the same student year one and year two, you are comparing. So it's two group we consider, but maybe the pair one as same student. So this is if not the same student, but different student we want to compare year one, for this batch, year one of that batch, then we do independent t-test, compare the mean. Okay. But if more than two group, like we want to see this year result of year 5, year 6, year 7, year 8. So more than two group, we use ANOVA, statistical analysis. Okay, this is for comparing mean. Okay, and if data is normally distributed, but if data not normally distributed, how you are going to compare? Then our statistical analysis, we choose different, like if two group, we choose Mann-Whitney test and the Wilcoxon match pair sign rank test, which is for the pair one, like for the same people before and after. Okay, something like that. Suppose same patient, you want to see the, you want to measure something before surgery, after surgery. So what you can do, the pair t-test, if parametric on data normally distributed. If not normally distributed, then you go for Wilcoxon match pair test. Okay. And in case the non-parametric data, you want to compare mean and it's more than 2, then we use Kruskal-Wallis test. Okay. This is the compare continuous variable for comparing means. Okay. For the relationship, we can see the correlation or we can see the association, which is regression. Okay. This is the outcome data when it's continuous, like 1, 2, 3, 4 blood pressure of the patient. So this is continuous data. Okay. You want to see the blood pressure of the patient at different stage or different things. So it's continuous data. We need to choose this part. Okay. But if your data is categorical, then what you are going to do? Categorical data, categorical data, we use the different way. Like normally ordinal, you remember ordinal and nominal data are categorical data, but sometimes for the scale variable, like the number, numerical data also, we make it categorical. Yes, no, we make it, or we divide into 2 different groups, we categorize it. Okay. For the categorical data, if we want to see the association between exposure and outcome, and if it's case control study, we normally do the odd ratio. Okay. If it's a cohort study, we try to check relative risk and 95% confidence interval. And sometimes we do survival analysis also, a different kind of analysis, that one. And if we want to check the hypothesis, is there any difference between the different group outcome and exposure, then we use the chi-square test. Okay, this is for the categorical variable. This is the relevant information I could provide. Maybe in the workshop we can go through in details. Okay, these are my references. You can contact me in case if you want to know anything. Okay, and thank you. That's all.